All right, good afternoon, everyone. Hopefully today in our camp things went a little bit smoother for you, but just in case there are still some issues in terms of balancing equations, I figured I'd go ahead and put together a little tutorial that will help us with this idea. Now, in terms of balancing chemical equations, we have to have some sort of foundation that we're going to utilize. Now, as we're going, also, sorry, I hate to interrupt here, but if you need to stop, rewind, pause, please make sure you do so. That way you'll be able to have the information very clear and straightforward before you. Now, our foundation that we're going to utilize here is we're now dealing with what we call the law of conservation of matter. Now, this law of conservation of matter basically says that matter is not created or destroyed in a chemical reaction. Most people will tend to think, okay, I mix these two things together and boom, this random stuff just happens and now I have something completely new. But what we're finding from this is that this new material, this new substance is really just made from the things that we originally mixed together. They've been rearranged, they've been sort of put into different places, but it's still the same material. So let's look at a couple of steps and a couple of examples to help us to understand better what we're going to be doing. Now, this is our first example. We have aluminum bromide, AlBr3, plus potassium sulfate, K2SO4. When we mix those two things together, it's going to yield for us potassium bromide and aluminum sulfate. But we have a problem. Our first problem, is if we look at both sides, we have more aluminum on one side than we have on the other, and we have more potassium and sulfate ions on one side than we have on the other. The question is, how do we fix it? How can we make it work so that we end up and this all makes sense? So, let's move on to the next slide. We have a couple of steps that we're going to need to follow in order to do this. First step, we have to write the equation. So, rewrote it, everything looks nice and clean, and we're ready to move on to step 2. Step 2, we need to identify the exact species or the types of atoms that we have represented in the equation. So, if we're paying attention to this, we see that we have potassium, we have bromine, and we have aluminum. Now, notice my note here. Do this for both sides. You can't do it only on one side, because remember, what we start with, we have to finish with. So, we have to have potassium, bromine, aluminum, and sulfate ions on both sides of the equation. So, moving on to the next part. Step 3. We have to count up how many of each we have on each side. So, by doing this, let's see. We already know we have these 4 things on both sides. Let's take a look at our equation. On the top, we have aluminum by itself. We're looking to the left. We have 1 aluminum, 3 bromine, 2 potassium, and 1 sulfate ion. Remember that the sulfate, SO4, is one piece. It all moves together. And so looking at the other side, we have to do the same. So we have 1 potassium, 1 bromine, we have 2 aluminum now, and 3 sulfates. So right now we are not balanced. We have to figure out how to balance it. Let's move on to the next step, which is going to be, step 3 is we have to add to each side, add bromine or potassium or whichever atom we need to each side until it's balanced. So, if I'm looking at my equation again written, here we go. I want to follow a certain pattern as I get started. That pattern is going to be what we call penguins may not have oxygen. Now, although this sounds cruel, remember it's not actually directed towards penguins, it's just a way for us to remember the priority. The P stands for polyatomic ions. The M stands for metals, N nonmetals, H hydrogens, and O, of course, oxygen. This is going to make it a little bit easier for us and give us sort of a system to work through as we do this. So, starting off, we want to look at our polyatomics. Now, the key for a polyatomic is it's going to be possibly 2 or more elements that are stuck together and you'll see them together on both sides of the equation. So, first thing that we notice is we have our sulfate ion. The sulfate, we have SO4 on the left, and then we have 3 SO4s on the other side. So what we're going to do is we're going to go ahead and add so that we can balance out our number of sulfate ions. So now I have 3 sulfate on the left and 3 on the right. So next move, we say we need to go to our metals. So start at the beginning with aluminum. Aluminum, I have 1 on the left and 2 on the right. So I got to make sure I have 2 on the left as well. From there, we now move to our potassium. I have 6, as denoted by K2. So I have 3 of those, so 6 on that side, so I have to have 6 on the other. Sort of speeding through this part a little bit. If you need to stop or take your time, make sure you break it up how you need. Now, in the process, now I need to go back to my nonmetals. Non-metal in this case, the only one I'm dealing with is bromine. Bromine, I have 6 on the left. And now since I've fixed my potassium, I also have 6 on the right. So now everything looks balanced. Sometimes this works out where you have to go back and forth a few times. But still trust the process, continue to go through each step until you have everything completely balanced. So make sure you take your time, go through them, check them a couple times just so you're on the right page. Now, we're not technically finished yet. We got one more step. Our step 5 is going to be write the coefficients. Now, from your math classes, you'll remember that coefficients always go out front. In this case, all we're going to do is write the number of how many times we've written it here on the page. So we have AlBr3 written twice, so we have a 2 in front of it. K2SO4 is written 3 times, so we write a 3 out front. We have 6 KBRs, so we write 6 out there. And we have 1 Al2SO43. So we leave that as blank. With this, now we're finished with this example. Now, this leads us into our next step, though. Now we need to practice this, because it's one thing to say, okay, now I've gone through it, it makes sense. It's another thing to put it into practice. So, moving on to the next example. We have iron chloride plus sodium hydroxide, and it says that we're going to yield iron hydroxide and sodium chloride. Reminding us here on the side, we have our PMNHO, penguins may not have oxygen. So, let's go through the process again. We have to start with our polyatomics. I have 1 hydroxide, OH on one side, and I have 3 OHs as denoted by our subscript 3 here on the side. So I have to match it up. Oops, jumped ahead a little bit. But as we see here, I have now my 3 sodium hydroxide, and to balance out, I then went to my metals. Metals is step 2. I had 1 on the left, 1 on the right. In the process of adding to my hydroxides, I also added sodium. So I have to add sodium to the other side as well. This allows me to balance out my chlorides as well as my sodium that I was dealing with before. Another example, and then I have one that's left for you. Take a little bit of time. Take a look at this. We have HCl plus CaCO3 is going to yield calcium chloride, water, and carbon dioxide. As you're taking a look, follow through the process. Take a few moments, look at it, and you want to probably pause it here, and then that way you'll be able to check it in just a moment. I'll pause now so you can pause it and come back in a second. All right. Now, by this point, you should have gone ahead and finished it, and noticing that it's actually much simpler than one would think. As balancing it, all we have to do is add 1 hydrochloric acid, so we end up with coefficients of 2, and the rest would be 1s, which we are able to leave blank. Now, I leave you here with your challenge. Take a moment, look at the example, and I want you to balance it and bring it into class tomorrow, bring it into the camp tomorrow, and check to see if you are correct. If you are, we'll see how we can go and get you moving on to bigger and better things. Again, make sure to write down any questions you have, and I am always willing to work with you, answer any questions that you have. Have a great evening, and I'll see you tomorrow in class.